All right, guys, we are on page 22 of your note packet. We're going to work with solving some log equations today. So you can see the first thing I have just a few strategies, steps to follow along with. So as usual, you guys can pause your video, take a look at those, write them down, but I'll talk through them as you are jotting some things right now. So first thing, we're going to talk about three different types of equations today. So that's your first job, is to identify or determine the type of equation you're working on and what's the best strategy to apply when you're working on that equation. Second thing, you're going to solve for x or whatever the variable may be. And the third thing, we need to check for extraneous solutions. So if we think back to our domain of these log functions, if I have log of x or log of something here, and we want to find the domain of this function, we know that that x term must be greater than 0 for it to work. So if I do log of -5, log of -1, log of 0, those are things that would produce an extraneous solution. So we're going to have to go back and check those, kind of like we did at the beginning of the year when we checked for extraneous solutions for those restricted domain questions. All right, so to start, the first type of equation you're going to look to identify are equations with a same base logarithm on each side. So to solve, you're going to kind of treat it like a same base exponent. So if we have like 2 to the x equals 2 to the 3x minus 4, since the bases are the same, it means the exponents have to be equal. And the same thing applies for log functions. So if I look at number 1, there's really not much to do here. I have log base 10 of x plus 2 equals log base 10 of 5. Since both of those logs are the same, there's one log of something equals the log of something else. That means that the two terms kind of within those logs have to be equal. So all we have to do on this question is set x plus 2 equal to 5. We subtract 2 from both sides. X equals 3, piece of cake. All right, we plug it back in. That does not produce an extraneous solution, so we are good to go. All right, letter B. We're set up. We have log base 2, log base 2, log base 2. Now here's the problem, and it doesn't work for exponential functions either. For this to work, there has to only be one term, one base on each side. So because this side of our equation has two of those log terms there, I can't just drop all the logs right now. So you have to be really disciplined, really thoughtful about that. I can't just cross those log base 2's out. The first thing I have to do is use the rules we discussed last class and combine those two log terms into one. So we have log base 2 of, and remember when we're adding logs term together, we combine them through multiplication. So it becomes log base 2 of x times x plus 2 equals log base 2 of x plus 6. So now we're set up. Now we have log base 2 of one thing equals log base 2 of another thing. So now we can set these two things equal to each other. So I'm going to do a little distributing. We have x squared plus 2x equals x plus 6. And we just go from here. Subtract x from both sides. Subtract the 6. We have a nice quadratic equation. We factor x plus 3x minus 2. I think I'm good there. I'm going quick. X equals -3 or x equals 2 are my two answers. All right, so I know I flew through that, but if you want to pause and rewind, that's obviously something you should take advantage of. And we're done. We have our two answers. But keep in mind what I said earlier. We always need to check for extraneous. So if I go back up to the top and I plug in 2 there, 2 there, 2 there, that works out no problem. This is actually a fun one to try to check your work because those are all logs you can identify without your calculator. So, log base 2 of 2 would be 1, for example. So anyway, x equals 2 works. But if I plug in -3 up here, log base 2 of -3, right there, instantly we have to reject that answer because it's negative. All right. If you want, if you think you need some more practice, you can try this one on your own. I'm going to have you pause now, and I'll wait about 5 seconds so you can pause. Then I will show you my answers. If you don't think you need to try it, you can move on. Okay. So a very similar question. We combine the terms. We get rid of those natural logs. And the same thing, we always have to check for extraneous at the end. If I plug in x equals 6, I have no problems. But if I plug in x equals 1, I end up with some extraneous solutions up top, some undefined values, I guess I should say. Log of 1 minus 2 is a log of -1, which we can't have happen. Okay, so take another close look at that if you need to. Ask me for help if you need to. I'm going to move on to the next strategy. Okay. Next, exponential equations with no logarithms. All right, so exponential equations where there's no log terms written. This is really just the straight inverse. This is why we have this inverse. 2 to the x equals 27. What we could do is see if we can do this as a same base equation. So 2 to the x, and if we want to rewrite this as 2 to the something, that that doesn't work with the number 27. So all we need to do here is rewrite this in exponential form. So we have log base 2 of 27 equals x. And there is no need to go any further than that. We are done. I don't want to go further than that. That's a pretty exact value, a pretty exact answer, and I don't need to type it into my calculator. We're good to go there. All right. Letter B, e to the x equals 72. Same thing. This is the reason why we have natural logs. So we have log base e of 72 equals x. So if we think about rewriting it like we've been practicing, log base e of 72 equals x, and we are done. Okay, so I'm going to walk through letter D with you. You are free to kind of pause me and quiet me down for a minute and try it on your own, but I'm going to walk through this one. I'm also going to have you do letter C on your own. So for letter D, our first order of business, I don't know why I wrote that +3, but our first order of business is we have to isolate the exponential term. So we can't start rewriting things until we have this by itself. Same thing for letter C. We can't start rewriting until we isolate that exponential term. So be really careful. We talked about the order of operations a lot lately. We have to divide by this 4 first. What this is, right? This is 4 times e to the 2x. It's not 4e to the 2x. It's 4 times e to the 2x. So we have to divide out by that 4 first. So we're left with e to the 2x equals 5 over 4. Now we're ready to go. All right, so I'm going to work up the side here. Now we can rewrite this. It's an exponential equation. So we can use logs to undo it. So we have log base e of 5/4 equals that exponent. We divide both sides by 2. We have x equals the natural log of 5/4 over 2. And that's as exact as we need to be. We don't need to go further than that. That's pretty much as simple as exact as we want it to go. We could put it into our calculator and get a decimal, but I think that's a good place to stop. All right, so same thing. If you want to try letter C, go ahead and pause. I'll give you about 5 seconds to pause, and then when you're ready, you can unpause, and then I'll show you my answer. Add 2 to both sides, rewrite, divide by 2. Very similar to the question right next to it. All right. Moving on. Letter E is unique. This isn't really an exponential equation. It looks exponential because we have, those e to the powers in there. But all this really is, when you boil it down, when you see that e to the 2x, how do you get e to the 2x? E to the 2x, if you work backwards, is the same thing as e to the x times e to the x power, right? When we talked about multiplying terms with the same base, we add the exponent. So that's another way to think about e to the 2x power. That's really the same thing as x to the first times x to the first, which is x to the second. So when you see a question set up like this, you can just think about it as a quadratic. All right, you can think about this, if it helps you to rewrite it, you can just kind of think about it instead of e to the 2x power, like it's an e term squared basically, you can just think about it as x squared minus 3x plus 2 equals 0. So we mentioned this way back early at the beginning of the year. If I want to think about this a little more simply, I can let x equal e to the x. So I can just rewrite all my e to the x powers. I can just rewrite them as an x. And that helps some people kind of simplify their thinking, their thought process when they're looking at these questions. So I'm going to write it. I'm going to continue on from here. If you want to think about it like this, you can, but I'm going to show you what it looks like. So how do we multiply by e to the x? Or how do we multiply 2e to the 2x? That's just e to the x times e to the x. So this is actually just a really nice factorable quadratic type function. You could also complete the square. You could also use the quadratic formula for this. It's all very related to things we've kind of done before. All right, we're going to have plenty of time to practice these. These are tough. But now we can just solve it out. So in order to multiply to 0, we have two ways. Either e to the x minus 1 has to equal 0, or e to the x minus 2 has to equal 0. I add 1 to both sides. I have e to the x equals 1, e to the x equals 2. And now I rewrite these these exponential terms as log terms. So log base e of 1 equals x. Log base e of 2 equals x. That's a nice answer. And remember what we talked about when we're evaluating is anytime you have the log of 1, log base e of 1, log base 10 of 1, log base 500 of 1, that is always going to be equal to 0. So we have x equals 0 as one answer, x equals natural log of 2 as another answer. All right. So if you felt a little bit, this one's a little bit weird, we'll talk about that in class. We'll have plenty of time to practice those. All right, last one. When there's log only on one side. This is very, very similar to the one we did above, where there's an exponent on one side. Here we just have a log on one side. So to undo a log function, we write it as an exponential. So here we have our base e. How do we break out of this log? We rewrite it as an exponential. E to the second power equals x. And we're done. Letter B is kind of a fun one. We can actually do this two ways. And if you think of this the other way that I'm about to show you, that's awesome, and you can play around with it, and it's really neat to see how both answers are arrived at. So I'll even put a little line here down the middle. So if you want to mess around with this and try it a different way, I think that would be really worth your time. Maybe we'll even do it in class. But what I see here, I have this log term, log base 5 of 3x. This 2 out front, and this is where you can kind of go a different direction with this, but that 2 out front, I'm gonna get rid of that 2 first. It's gonna make the problem a little bit easier. So what I have here is log base 5 of 3x. I wrote that wrong. There's a 2 there. Log base 5 of 3x equals 2. And now we're really at the same spot I was in the last question. I have a log equation. I have a log on one side. I have a constant on the other. So to break out of this log, I'm going to rewrite it in exponential form. So 5 to the second equals 3x. Divide both sides by 3. I know 5 squared is 25, so I'm going to do two things at once here. X equals 25 thirds. All right, and I kind of glossed over some things. I'm trying to work quick and keep this video short. Keep in mind, we always need to be checking for these extraneous solutions. So here, log of 1, that's okay. Natural log of 2, that's okay. Log base 3 of 128, that's okay. When I check my work here, x equals 25 thirds. When I plug that in for x, that's okay. It doesn't give me a negative number. It doesn't give me 0. So keep in mind, always checking for extraneous. So I'm done. This we're going to do as a bell ringer next time. We'll probably get into our breakout rooms or into our groups and try that one out as a bell ringer. You can try letter C right now, like we've been doing. I have my work shown, so you can pause, try this one out if you need to. But yeah, rewind, rewatch anything that I went too quickly on. But next class, we're going to have a ton of time to practice all these. And then the class after, we're going to get into some really kind of challenging, fun type of problems where we can be very creative with how we're solving them, which is cool. All right, so try this one out. Pause now if you want. And there's my work. So actually, there's some of my work. So I subtracted 5. Let me show this next line here, might as well. I divided by 2. I have ln x equals negative 1/2. And here we actually could write this a little more nicely, right? That negative exponent, well, I guess it doesn't really make a difference. But that negative exponent, we know we can rewrite it 1 over. So either way, e to the negative 1/2 or 1 over e to the positive 1/2 is fine. So there's my work. Let me know if you have questions. I will see you in class. Bye.